Is there a way I can tell who's actually viewing the whole thing? Oh, because I'll just go through the lesson and upload this to YouTube. That might be a little bit better. All right, guys, so here's the thing. We're going to be talking about density today, okay? So density is simply the amount of mass per unit of volume. That means the amount of mass that you have in a specific space, all right? Remember that the volume is just the space that something is occupying in the real world. And the mass is the amount of matter that's contained in an object. Okay, so we do have density defined as the amount of mass per unit of volume. We already know what mass and volume is, and that's the only two things that we need in order to find the density, in order to calculate the density. Remember that you guys are not doing any mathematical process. You guys are using the calculator in order to get the whole thing done. So that being said, we're just going to go ahead and continue with the presentation. So density, the formula for density equals mass, that we already know what that is, and we know that we measure it by putting any object on a triple beam balance divided by the volume. And the volume, it depends on what are we measuring. If it's a regular solid, you guys remember that we need to be able to measure the dimensions of it. Let's say a cube or rectangular prism. Those are things that we can measure its sides, the length, the width, the height. And if it's an irregular solid, then we go and we have to get ourselves a graduated cylinder and try our best to measure the water displacement. Remember, the volume is not going to be the total amount of water that you can measure on the graduated cylinder, but only the increased, like let's say that you have 30 milliliters in a graduated cylinder, and then you drop, I don't know, a toy or maybe a ping pong ball on a graduated cylinder, and it goes up from 30 to 40. The volume of that object that you just dropped, it's only 10 cubic milliliters or cubic centimeters in this case, because this is solid we're talking about. So here's the formula right here, the way we see it on a standard algorithm. So it is the mass. You guys remember this one? This is a dividend, the mass right here, divided by the volume. Okay, you do the process right here, your quotient and everything, and that's pretty much all there is to it. So just to make sure that everything it's in place, we got the formula right here. It's density equals to mass divided by the volume, or in the standard algorithm, we go density equals the mass divided by the volume. Simple, perfect, and the only two things that we need to have in order to find the density is the mass, one found by just measuring the object on a triple beam balance, it's measured in grams, and the volume, it's a cubic unit, okay? Depending if it's a liquid, it's a cubic milliliters, or if it's a solid, it's a cubic centimeters that we're using, all right? So you guys have to remember that the water's density, it's 1 gram over cubic milliliter. The density of a substance doesn't change depending on its quantity. Remember that we mentioned that, for example, doesn't matter if I'm holding in my hand 1 gram of gold or the entire Mount Rushmore of gold, the density of that specific element, in this case the gold, will be the same thing always. If the mass is greater than the volume, then the object will sink, because when you have a greater numerator than the denominator, let's go back to this. When you have a greater numerator than the denominator, your result, your answer for this division problem will be greater than 1. And what happens when it's greater than 1? The object sinks in water because the density of water, remember, it's only 1. If a mass is less than the volume, then again, if a mass right here is less than the volume, let's say 1/4, okay, 1 and 4 right here, you know for sure that the result for that division will be less than 1. Therefore, your object will float. Why? Because the density of that object, it's less than 1. If it's less than 1, then it's less dense, meaning that it will be floating in water. More dense equals bigger. It's not that. Let's just forget about that. It's not. You can have a ship. A ship can float. Ship, it's an extremely big object, and it does not depend on how big the object is. It's usually related to it, yes, but it technically doesn't depend on it. So it's we always gonna be dependent on the density of the object that we're working on, and when it is where it is placed. Like if it's water, if it's salt water, if it's cold water, warm water, depending on that. So to find the density of an object, I need a mass and a volume of that object. So let's just find the mass of these apple right here. Let's say if it's 96 grams, okay? And you have a volume of 12 centimeters or cubic centimeters, right? So all you have to do, again, you have the data right here, right? So all you have to do is just replace mass and the volume, and you already have it right here. You got the mass and the volume. Usually you are provided with these two things. Usually you get provided by the mass because we're not gonna be having any triple beam balance during the test. But you are pretty much capable of calculating or finding the volume of an object when given its dimensions or the displaced water it's taken. You either will have like a graph of graduated cylinders, or the problem itself will talk about how much water was displaced on that specific problem. So once you have this, you have the mass over the volume, or mass divided by the volume, and we do have the data right here that's being provided by the problem. Then I'll fill my known information and plug it into the formula of density, which is density equals mass over volume. What we do after that is we just find density by dividing it using the calculator. We didn't use the cowboy horse method to remember where to put the numbers because we're doing it in a fractional method. But if you guys remember, the mass goes inside of the house. And when you guys saw the picture, but you guys have to remember that the mass goes inside of the house, the volume, which is a horse, goes outside of the house, meaning that this is the house right here. I don't know. I just don't like that method as much as others do. So right after that, you just divide and you get the answer for it. The answer for that division specifically will be your density. You found your density already. It's 8 grams per cubic centimeters. So other than that, that's our unit. We know it. And let's go right now with this couple of exercises right here. So if we have to find density, you guys have to remember the pyramid. If we do have to find the density, I'm asking you to just to get a finger or cover the letter that you're looking for. Let's say density, we're covering the D, and we're left with the M divided by the M. Therefore, the formula for the density, you can see it right here. It's the density equals mass that we do have divided by the volume. Mass divided by volume. Right here, it's highlighted, right? Let's say on the second part of this, what is the volume? They're asking for the volume, but they're providing the mass and the density, which is its unit. So technically what we do, we cover the V for volume, that stands for volume, okay? And if we cover it, okay, let's say we cover it, we cannot do it right now, we cover this, we are left out with the mass divided by the density, and you are being provided with these two. So all you have to do is just to plug it in the mass divided by the density, and therefore you found your volume. The only one that it's going to be multiplying, or it's a multiplication case in this case, it's when they're asking about the mass. Okay, this is, if you cover the M right here, you get to see there's a multiplication symbol right here in between the D and the V, the density and the volume. So you get to see the formula of mass, or to find mass, it's the density times the volume. So as you can see, it's pretty straightforward. It's nothing extraordinary. Plus, you're using a calculator just to measure that, just to have this information in your hands. So I don't think it will be a problem with this if you follow the formula and you know what you're talking. Like if you know the data that you're having, Solve is going to be provided to you. Also, again, when you are not given the volume of a solid, if it's a regular solid, you guys have to remember, please remember, that for solids, you're going to be using the length times the width times the height to find the volume. Easy, easy, easy formula. We've already worked with this in 4th grade. We already worked with this in 5th grade. We know for sure how to find volume by having the length, the width, and the height. You're not going to be finding any of these lengths, of these sides of the cube or the rectangular prism. You're going to be provided with this information. All you have to do is to find it by plugging in the length, the width, and the height into the volume formula for regular solid. It changes though when it's an irregular solid. When it's not a regular solid, it's an irregular solid. We need to find the water displacement. All right. So what we do, and this is nothing complicated as well. You guys went through this. You guys did the experiment with me. So technically, what you have to be aware of, it's how much water do you have before dropping the object in that graduated cylinder. So you can either use the strategy that I taught you guys, start, okay, the start volume inside of the graduated cylinder, volume of water, the amount of water. It's a 45 milliliters of water. Or, and then we get the final one. So that means that you start with this, and then after you drop the object inside of the graduated cylinder, you get another or different amount. That means the water is being displaced. Remember that it's not growing or increasing its size. You're not pouring more water into it. You're just having the water displaced. That means that this little object right here, in this case, the star, it's occupying some space inside of that graduated cylinder. All it is that it's taking some space. It's just like when you have tea, when you go to, the best scenario in this case is Starbucks. Starbucks, when you are asking for a freshener or something like that, they do fill it in with ice and then put a little bit of that liquid that you're buying. So technically you're getting less liquid because the ice is the one that's occupying all the space inside of the cup. All right? Or let's say, for example, in the other case, when you're at home and you have this cup with the tea or soda or water, and then you put in lots and lots of ice until the water is pretty much like top of the cup. So those cases, you're displacing the water. You're not adding more water or liquid to the cup. You're just displacing the water by putting ice or any other solid object in it that also holds a volume. So to find an irregular solid's volume, okay, all we have to do is just to pay attention to the water that's been displaced. And the easiest way to do it is just to pay attention to the amount of water that you have prior to dropping the object into the graduated cylinder, and then the measure that you have of water after you drop that object in that very same graduated cylinder. So in this case, we got a start volume of water or quantity of water of 45 milliliters of water. After we dropped the object, okay, it increased or grew. The water was displaced all the way up to 50 milliliters of water. Now, you see there's a difference. The displaced amount, it's only the differences between these two levels, 45 and 50, which is only 5. Therefore, my volume for this specific case, in this specific section right here, let me just highlight this only. In this specific area right here, it's only 5 cubic milliliters. In this case, this is a solid, so it's a 5 cubic centimeters. That will be my volume. I know it's a little bit abstract because you cannot see right now, but we worked it out in the lab and you guys found it like fairly easy. So if you find yourself struggling with it, I highly recommend you to go through this lesson over and over again until you find out how to calculate the density by finding the volume first. So technically, what you're doing here, okay, it's finding the volume first to then be able to have mass over the volume that you're calculating and you're going to be putting in here. So it's technically and fairly easy process to follow, but again, it's not a straightforward answer. So once you find the volume, it is not telling you the answer of that problem. We're always going to be finding the density unless it's stated otherwise. Let's let that sink in. We're always going to be finding the density unless it's stated otherwise. Is that clear? Make sense? What I'm trying to say is that you're not going to be given the density unless it is labeled as density. You're going to be finding other things like such as mass, such as volume, and then plugging that data that you found into the density formula to find the answer for your problem. So it's a multi-step problem. It's not like you're going to be finding the volume. Oh, it's been displaced 5 milliliters of water. Therefore, the volume is 5, and you're going to go and put 5 in one of the options because chances are that that's going to be one of your options. It's always going to be there's always going to be one answer trying to trick you into getting that specific thing because you already found that value. And I get it. Sometimes it's the easiest way to do it, but let's just remember that we're not looking for volume right now. Volume is just one of the things that we need in order to find the density, which is what we've been asked. Now that that's been cleared out, just a brief review of this. To find the volume of a regular solid, we measure its size, we plug it into the formula of volume of a regular solid, and then we find the volume. The mass will most likely gonna be provided, and then you find the density by using the formula. Density equals mass over volume. You already know this formula. For for the irregular or not regular solids, we use water displacement. That means you have a graduated cylinder with a certain amount of water, you drop it, and the water that's been displaced, it's the amount that this object inside of the graduated cylinder is taken. Now, why the water is being displaced? Because the water is a liquid and can take the shape of pretty much any container that it's holding it. So if you keep on dropping things, it will move around that object, okay? Displacing, it's making sure like it's that moving its place from one level to another, because that little object that we just dropped, it's also taking place inside of that very same graduated cylinder. So there's that. We got density formula. We got the triangle explained, which is this. We got density formula. We got the volume formula. We got the mass formula. We know how to calculate the volume when we have the regular solids. We know how to calculate the volume when we do have an irregular or not regular solid. Guys, that is pretty much everything that's going to be assessed tomorrow morning and afternoon. I wish you guys the best luck. And
Mr. Newman, at what time are you gonna stream?
already did. I'm streaming right now.
Oh.
Already did the lesson. I'm gonna upload that video to YouTube so you can see it. It's explaining everything about like the density and everything that we talked about, and everything is gonna be assessed tomorrow. for the
Yeah.
test, and that's pretty much all there is to it.
Never thought I'd meet a teacher who played Fortnite.
Yeah.
That's cool.
Thank you.
Take him. Wait, let me get you.
Oh, kill him. Oh, he's low, he's low, he's low.
Yeah, he's really low.
You're gonna kill yourself.
Didn't.
Why did you kill yourself?
Guys, what?
Do they have a mic?
Just like creative.
Let's go.
I'm about to clap Luis, bro. He keeps on talking smack, bro. Come on now.
Go Evan, create it.
Boy,
You
look
got
at
three
your
weekends
default, boy. Look. This is the only dance he got, boy.
Mean nothing. That don't mean nothing. I'll destroy you.
It's not the same thing, but different. Oh, never mind. It's the same thing. He gives us our- He's not like-
The building part of it.
GG's. Second place. Come on now. Adrian died. Help with that.
Alright, got it. So we get all the weapons at the beginning. We don't have to look for weapons, right?
No, we don't gotta look for weapons. It gives us weapons.
Alright, understood. Let's go.
Oh, boogie bomb somebody. Boogie bomb somebody. I don't spray another.
Alright.
I'm going easy on Untitled. Shut up, yeah, shut up. but
Shut up, bro. That's why I killed you.
you're garbage.
Look at that.
You're
Irvin,
garbage.
Irvin won and eliminated no one. So he's always like building and gets high ground. So he waits for everybody to get killed.
Who?
Irving camping.
Look at that. Look at that.
Look at that bot. I was trying to pickaxe him, but nah, I didn't want to keep his storm. I'll see somebody.
I told you. I told you.
But Adrian's garbage. What? Oh, you got destroyed.
Shut up, bro. That's why you don't know skin.
You make your career.
You're picking it up from Mr. Newman. Nothing down, nothing in, nothing down.
Ah. Now, if I get my hands on that building thing, you're done. I didn't get any. What is this? No weapons. No, it's just storm. What is that?
Oh my god. GG's.
I'm gonna have to get high ground immediately.
Get it, camper.
True. 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 It's really fun to hear you, bro.
You're done.
Hello, Mr. Newman.
Who's this? Who's this?
Bradley.
Bradley. I'm playing with Irvin, Atreyu, Adrian, and I don't remember who else was playing with us.
Right.
All right, guys. I'm gonna go have dinner, real quick. So I'm
Alright.
just gonna leave.
Right. What are you gonna eat?
Probably I'm gonna go. I think I'm gonna go with pasta today.
Oh, nice, nice.
Yeah, yeah. So I'll be right back in probably like 1 hour, 1 hour and a half. But by that time, you should go to bed. And remember that we got a test tomorrow morning. The video
Oh,
for
yeah.
the video for the lesson,
forgot.
the video for the lesson will be on YouTube right now because I mean it was part of the stream at the beginning, and then I started playing. But the first like 20 minutes, the 15 minute, 20 minutes was the density of the lesson. So I'm just gonna upload it to YouTube. You guys watch it and
Okay.
then go to bed, get some rest. All right.
Alright.
All right, guys. Thanks for playing. Bye bye.